We want to split an array into two parts to minimize the absolute difference between the two sums. The goal is to design an algorithm that runs in linear time and uses constant extra space. Here is an example array. We place a cut between two elements. The sum on the left and the sum on the right depend on where we cut. The difference is the absolute value of left sum minus right sum. Let the total sum be capital S. If the left sum is P, then the right sum is S minus P. The difference is the absolute value of P minus parenthesis S minus P close parenthesis, which simplifies to the absolute value of S minus 2P. So minimizing the difference is the same as making P as close as possible to S over 2. We can find the best cut in two passes. First, compute capital S by scanning once. Second, scan again with a running prefix P. At each cut position, compute the absolute value of S minus 2P. Keep the position with the smallest value. That is linear time and constant space. Pass 1. We compute capital S. Watch the scanner move across the array and the running total update. Pass 2. Now we build the prefix P and evaluate the absolute value of S minus 2P at each cut. We mark the current best cut with a star. Why does this work? The difference equals the absolute value of S minus 2P. So the best cut is where the prefix P is closest to S over 2. On the number line, we hunt for the closest approach to the middle. A second example, including negative values. We still evaluate each cut with the absolute value of S minus 2P, so the procedure is unchanged. Finally, the complexity. We scan the array twice, so the time is linear in n. We only keep a few counters, so the extra space is constant. The key formula is the absolute value of S minus 2P. Track the prefix P and choose the cut with the smallest value. That is how to split an array into two parts to minimize the absolute difference between sums with linear time and constant space.